Okay, so hi everyone. Awesome that you're all here. I'm Jatka, this is Jens, and we will now present Snap, a programming language that we work on together with Bernat and a few other people that I'll mention in a second. And what we want to do with you today, or what you have to listen to, is first I'll explain shortly what Snap is and why we care about it. Then we'll show our 3 guiding principles. And if we have time in the end, Jens will show what's under the hood of Snap as well. Okay, so Snap is a visual block-based programming language, and I'll show that to you in a second. It's also like Microblocks Live and Parallel, and we develop it together with people at UC Berkeley in California. So we have 3 people, us 3 working together with 3 people from UC Berkeley, developing this thing together. Snap is a blocks-based programming language, but it's aimed at high school and college students. But as you will see in a second, you can basically start whenever you want with it. Okay, our 3 guiding principles, let's start with the first one, is low floor. So this means that we really want to have engaging activities for entry-level programmers, so you don't get scared away, and that we really want to have fun activities that they can do. To show you that, I've built a super simple, what we call a micro world. So this is an extension of Snap that I customized myself. And this only has these 3 blocks here. And as you can see, you don't even have to read to use them. We can just try them out and see what happens. So let me increase the stage size a bit. So I can click on that. As you can see, it's live. So I'm clicking on it while it's in the palette and it's still doing things. I can click on that, nothing happens. I see, oh wow, there's an input slot here. Maybe I could type a number in here. Let's see what happens now. Ooh, okay, it's doing something. This is stamping a flower, and this one is supposed to be a sponge. It's clearing the stage again. So since we're working with flowers, let me draw a beautiful petal real quick using the costume editor. Let's do a yellow one. Oh, that's brown. Okay, and then let me draw something, jip, and let me even fill it maybe. Yeah, wow, this is very beautiful. And then let's make this even more beautiful. And that's important, move the rotation center, jip. And let's try the same thing again. Okay, this is pretty cool. So now if I want more flowers, I can build a larger script. So I can use the central area of Snap to build more complex programs. So I could go to a random position and draw another flower there, and go to a random position and draw another flower there. And so I could click on that forever. But it would also be cool to just have a forever loop that does that. So computers are really good at doing things automatically very often, so why don't I make a loop? So I already prepared this page here, and let's use for the look for the infinity sign, because what I want to build is an infinite loop. And let's just copy that. And then let's build our own control structure by just hiding it in the actual, no, we don't hide it. Let's just do it. So this is going to be a control block, and I'm calling it infinity. And this is going to have 2 inputs. One is going to be, no, it's only having 1 input. It's going to be the action. So let me build this block. I already have it here. So, okay, no, let's do that again. Jip. Sorry, I'll just delete that and start over again. Okay, I want to make a control structure. It's called infinity. I want to add a parameter to that, and this is the action that I'm going to run. I can even decide what I want this to look like. So as you might know from Scratch, our loops have the C-shaped, or from Snap, our loops have the C-shaped command structure. So I can click on that. And when I apply that, you see that I have this C-shaped block with this infinity sign on it. And now I need to decide what I want to do with this block. So first, I want to run the action. I don't have a run block here, so let me just open the hide blocks section. And because I hid all the actual blocks from Snap, and I'll show you how to do that in a second. And let me drag out one of the run blocks. Jip. And what I want to do is I want to run the action, and then I want to repeat the same thing, and I want to run the action again. So I think that's correct. Let's try it. So I made myself a forever loop, and let's clear the stage so we can actually see what's happened or what's happening. And let me drag this around here. And now I can run my program, and I built myself my own control structure, and it still looks very simple for kids, but all of you obviously could do that. So this is one thing that we really care about. We want really simple, entry-level, engaging activities, and this is one of my favorite starter projects. But we also want teachers to be able, educators to be able to build these microworlds very easily, and we want them to be able to customize Snap in a way that they can use it for their needs. What I also wanted to show you in this project, and let me make the stage a bit smaller again. You can have several what we call scenes in a project. So this is basically a project in another project. So I can now switch to that scene, and here I already prepared a petal, and you see that I have more blocks than I had before. I also have a separate stage, so I can switch between scenes, and we can use that idea to build something like language levels. So in the first micro world I just had that block that draws a flower. In the second micro world, I want learners to be able to build this flower block themselves. So we gave them all the tools that they need for that. So here, for example, we only have this block that stamps a leaf, so one of the petals. So what else do I need to build the flower? I want to do that several times, so I might need a loop. And this one, as you can see, has a number as an input. So I can specify the number of repeats. And of course, I need a turn in between. So what we want to do is we want to stamp. Let's do a flower with 6 petals. And then I need a turn in between. And also I built this block myself. And I want to turn 60 degrees each time. So let's clear before we draw a flower. Jeep. And then let's do 1. So this is how the flower block was actually built in the first thing. So we can help learners to gradually get new ideas. And then, which I find pretty cool, it's also super simple in Snap to prepare your own libraries. So I made one. If you have a kid in class that is just faster than the other kids, you can export a library and just let them add more blocks. So here I added a few more blocks. For example, these ones let me change the appearance of the petal that I have. So this one, for example, changes the size of it. Let's set this to 100, and then you see the petal becomes super huge. I can set that to 10. Let's clear again. Then it becomes super small. So maybe we want to pick something in between, and we could even do that randomly. So for example, I could add this here, and I want the size to be between 20 and 40. And then I get differently sized petals each time I do that. So if I do it like this, you see that this changes. And I really like that about Snap, that you can easily expand projects with fun ideas so they look differently and are more engaging, but you only need like 1 or 2 more ideas. This one, for example, switches to the next costume. So if I wanted to add another petal, let's draw one. Let's do the one that I did before, but in blue this time. Jeep, jeep. Let's fill it with something. Jeep. Okay, and then again, let's move the rotation center to one of the tips. And we can now use that, and each time we draw something, we draw a different flower. So the next one in line. And then again, we can combine that with what we had before and just create a beautiful flower field with the blocks that we made. How do you do that if you want to create a micro world? Let me go to the third one I prepared. So this is not actually a micro world. This is regular Snap with all the blocks that you have. So as in other block-based programming languages, we have different categories here. We have the palette on the left where you find all the blocks for a specific category. As I mentioned before, it's a live programming language, so you can just click them and something happens immediately. And what I also added here, or what I thought I added here but didn't, oh, that's unfortunate, is so let's just build it, is the project. So again, we want to have all the blocks that we used last time. So what we had was the next costume block, we had the set size tool block, we had the pick random block. We also need a division block. We had a repeat block. We had a forever block. We had a stamp block. And we had a turn block. And what was the last one? Oh, the second to last one was clear. And what was the last one? Go to random position. Awesome. And we need the go to random position. And let's assemble these so that we actually can make sure that our script is working. So for a flower, we want to repeat a specific number of times. Let's do 6 times. Then we want to stamp. Then we want to turn the number of degrees. That's 360 divided by the number of petals that I want, so 6 in this case. And before we wanted to do that, we wanted to go to a random position. So let's check that. That seems to work. Awesome. We wanted to do that forever. And so that all flowers don't look the same, we wanted to set the size to a random position, a random size, a random number. Let's do 20 to 30 maybe. And we need a second costume. So let's just duplicate that one and let's change the color a bit. Yeah, this is very different. Awesome. This is exactly what oh, wow. Okay. Okay, so we have 2 costumes, so we can actually also use the next costume block. And so we start with a clear stage. Let's add that at the beginning and let's see whether this works. Okay, awesome. And now if you want to build your own micro world, you can just go to the File menu and select Hide Blocks. And that's the awesome thing that we added in the second last, like the previous release. You can hide all the unused blocks. And if I do that, I only have the blocks left in the palette that I used for my project, and they are in these categories here. And I can even make the single palette that I had before by clicking on the settings menu and then selecting the single palette. And now you have all the blocks in like one palette, and you can make your own micro worlds that have all the blocks that that you need for your project that you want to do in class or with your kids or with some other people who want to learn programming. And then you can delete that, and then you have your perfect Parsons puzzle generator. And so this is, again, the low floor idea that I mentioned. We really want to have engaging activities that have a cool artifact that looks beautiful or is fun to do. But we also want to help teachers and educators to create these fun and engaging activities in a simple way. Okay, the second idea that I wanted to present, or that we think is, or that we care about, is wide walls. So we want to allow for a huge variety of projects, and the ones that we care most about are media projects. So we love this idea of media computation, meaning you learn general purpose programming by playing with sounds, images, texts. And one exemplary project for that is, for example, from Snap, you can access the microphone of your computer. So in this case, if it's running, it should be. This, for example, is a visualization of the frequency spectrum of my voice that's just picked up through the microphone. So this looks beautiful at the same time as it's interesting, because you can talk about sounds from a physical and computational perspective. And we love to do stuff with the camera. So this is another project that I like very much. This is pasting the webcam of my computer to the stage. Right now I set the transparency to 50%. Let's make it fully transparent. So the video is still there, but you can't see it anymore because all the pixels are transparent. And then I'm sending a message to the other sprite, and what's that doing is it's drawing dots on the stage which size corresponds to the brightness that it's measuring in the image that it picks up from the camera. And this is actually a pretty cool technique. It's called dithering, and this is how images were made in newspapers back in the days when you weren't able to print different colors. So you just did differently sized dots to get like a more deep color space. So this is what we mean with wide walls: allow a variety of projects that are engaging and fun, and that also kids who don't necessarily like Fibonacci might find interesting. And The last idea, for that I will hand over to Jens, is no ceiling. So as I said, Snap is a programming language that's aimed for high schoolers and early college students. So it's Scratch, but with all the awesome ideas that make programming fun. And Jens is going to show you these now.
Oops, okay. Thank you, Jitka. So, we're having kind of a conflict here because we want to have this low floor and the wide walls for the kids, but we're also having this idealist notion of blow off the ceiling. Like, we don't want to constrain kids. We don't want to dumb down the language so it's okay for kids. And this is kind of coming from the 60s when, you know, some of you might remember Logo had the idea that, you know, you don't make stuff easy for kids, but you make it welcoming for kids, but you don't constrain it. You let kids express everything they can. And this is only one part of the pedagogy. The other part of the pedagogy is geared, as Mark said, towards teachers, towards educators. Because if you look at these micro worlds that Jitka has shown, let me again go to, oh yeah, this is mine already. So here is a bunch of blocks. Like, these aren't the regular blocks. These are the ones that we made. Okay. I need to stay more in the center of, so y'all at home can see me. We want teachers to be able to build these exercises, to build these micro worlds for their kids. So it's not just us, you know, building something. Here's an exercise you can do with your kids, but there's a teacher, there's an educator who wants to teach something, as Jitka did, about what was then called, you remember, the total turtle trip theorem. That was kind of what Jitka showed you about. So we built a micro world to that. Which language are they going to build this sub-language in? Are they going to have to learn another language to build these little domain-specific languages? No, you saw Jitka build these blocks in Snap itself. And so we want to take this even further and find out whether we can maybe even invent a language that lets us build a block-based language inside a block-based language. And for this, we really kind of want to do things that we can do in the UI. We want to be able to do it in the language. So in this palette here, I made a little block, and it shows me some tools. So if I click on this, I'm getting some more blocks. And I can, again, hide these. It's a very simple block I can build myself that just shows and hides me some blocks. And now I can kind of explore some of these things. So I can, for example, look at this block, that the flower block, and I can see how it is defined. And see, it is defined with its own blocks. So I can open this and edit it, but I can also get the definition of this in a program. So now I'm getting the definition of this block, and I can see that it's a function. I can take this out, and I can do some other interesting things with that. So here is our split block. For example, I can split hello world by the space, and I get hello and world. I can split it by letters, and I get each letter. So what happens if I split a script by blocks? Let's make this even smaller. If I split a script by blocks, I'm getting a syntax tree, a table of the syntax elements in there. So I can do this with, you know, the definition of my flower block. And, oh, wow, so I can, so this is a table. So I can also flatten this. So I'm not saying I don't want the length of this, I want it flattened. So now I'm getting a list of all the syntax elements that make up the definition of this flower block. And that's kind of interesting, because now I can find out, for example, so here I can take out the turn block. And I can say, you know, do all of these. Let's does this list contain this turn block? And says, yes, the turn block is part of the definition of this list. So, but what about, for example, the clear block? Is that also in there? No, it's not present in there. So this is interesting. I could maybe discover something else. So what I can look at all the blocks that I have in this micro world. And this is a list of all the blocks in this micro world. So I'd like to find out which blocks contain this turn block. So I could say, you know, I want to filter from my blocks those that contain this block. Let's see whether that works. Yeah, so I'm getting a list of 2 blocks that all use this block. Now I can turn this into its own block. I make a block that says this is the colors of a block, and the block should be an input. So I'm saying this is a block. And in order to define this, well, I just did define this. I just dragged this in. And I say, okay, this should work for any block. So not just this block, but for any block. And so now I have this block that gives me the colors of, for example, this block. Let me see whether it works. So this block is used by 2 other blocks. And this block isn't used by any other block. And, let me see. Maybe I can get a whole report by looking at all the blocks and by mapping over all the blocks. And I want to see the block, and I want to see its colors, right? So what we're now doing is really an introspection of the system, of the block system in itself. So if I map this, I'm sort of getting this interesting structure. It's a data structure, it's a table, and it's a graph, really, a reverse dependency graph of all the blocks and the blocks it uses. And I get a report of the overall structure of my micro world. And folks, this is something interesting if you think about this. So we're starting with this easy, simple thing that we can build worlds for kids. And we want to build these little domain-specific languages, but we want to have a language that actually lets us build these things in itself. And this is why we build introspection and kind of all the goodies of functional programming into this language. But we didn't want to make it so that you kind of have to go down to memory addresses, but we want to represent everything in blocks. And this is kind of the idea of no ceiling. Because at one point, you know, we start doing this with kids, but we actually build it for the University of California at Berkeley, and they're using it for their introductory course of computer science for non-majors. And, you know, this goes up quite a long way. So we actually want to be able to do scheme in this and to really teach abstraction. So at one point, we really want to blow off the ceiling, and we don't want to do just only this imperative style programming where, you know, one follows the other and you've got the puzzle pieces. But we actually do a higher order function. You do kind of recursive, you build your own control structures, you build your own language. It's a little stiff and it's challenging to try to accommodate, you know, the let's draw a flower with a bunch of 3 blocks to let's invent our own programming language in the same environment. And in order to build such an environment, the whole thing that you see here, hey, you're nerds, I can show you, right? The whole thing you see here isn't using Blockly or a library, but what you're seeing here is actually an operating system that runs inside a single canvas element in the browser. And there's sort of a pill you can take to switch to dev mode, and you're sort of inside this environment that some of you might recognize looks a lot like Squeak. So if anybody you know Squeak? And so it's kind of the same morphic environment where you could just get, any things, you can directly manipulate them. For example, you can make this bold, but you can also use this to, let's make a slider. I can attach the slider, set the target to the string morph, to the font size. I can change it. I can make it horizontal, and now my slider governs, for example, the size, the font size of this. I can make other elements, like, for example, color palette, and I could set the target of the color palette also to the string, and now I can change the color and the size. I can still edit it. So this is basically our own system that is kind of self-sustained in the browser, and everything that you see in Snap is sort of an application inside this really OS inside the browser, and it comes with its own green threading model, which is how we do parallelism. So in order to go up on the ladder of abstraction, on the back-end side, we have to go kind of down to not the middle, but to kind of a middle of sorts of the browser. Okay, this was kind of our ideas. If you'd like to check it out, it runs on snap.berkeley.edu. Give it a try yourself. You'll find lots of material. It's open source, by the way. It's free and open source. It's an AGPL license, so if you want to know, so it's copylefted, so everything is open source about it. We write the front end, the back end, the community side. It's not as big as some other languages, but we've got a vibrant community. It's all hosted on GitHub. Please do contribute. Please do fork it. Many people have forked it. Please let us know what you think, and thanks for coming.
So I found that really fascinating, and as a Lisp programmer, I couldn't help but think about macros when you were showing the exploding of the blocks. So would it be possible, once you get the abstract syntax tree, to annotate it, let's say add a sound between each step, and then recreate a new block from an existing block?
Yes, if we had more time, I could show you this. We do have macros.
Okay, great.
Yes, so I showed you the split block, which takes apart the stuff. We have a join block that you could pass in a syntax tree, right? Yeah.
And you export it to an app on your phone. Can you do things with your phone afterwards?
Well, this is running in the web in a browser. So your phone can run the thing in the browser. What you get here is you can publish it as a URL. And yes, and then you can run it on the phone. And it's something I like to do with kids a lot. It's also interesting if you do stuff on touch devices, like on tablets or stuff like that. You kind of need to be considerate of which gestures you use, because you don't have mouse over, or so yeah, it's fun.
And you can also embed it on iframes in your website.
Yeah.
So if somebody's interested in that.
Yes, please.
I was wondering, like, in your mind about the future, do you see anything like that this is becoming more mainstream, and also for adults, like non-programmers building their own stuff with something like this?
That's a good question. I really have this dream that I think blocks-based programming, if we take away the kiddie stigma of it, and if we dare move on from this sometimes horrible imperative paradigm to the beauty and joy of functional programming, that, we get these expressions that actually make things easier to understand, that make things more accessible, and that this is a great way to actually, express many things inside professional development. So we write the software in a way that we like to use it ourselves, and we hope that it might convince others to actually build and embed this into enterprise applications. Because often enough, if you think about these low-code, no-code things, you know, you click together some pre-configured stuff, but then you need to write some glue code. And the glue code often enough is terrible and awful. And this is where I would love to see a block-based environment that has no ceiling.
It also makes more sense like that you have the blocks nested already in the
Yes.
ASP style, like with Lisp. This is Lisp with blocks.
It is Lisp. It is Scheme in the browser. Yes.
With all the no-code stuff, you always have the graphs that you have to draw, right?
Yes.
It's a totally different. Yeah.
Exactly.
And we do have stickers and buttons here. Take all you want.
Yeah. Yeah. Thank you very much again.